Hello friends, welcome back to Shixak Academics. We are continuing with our Introduction to C Programming course, which is specifically designed for absolute beginners. In the last video, we saw how we can write a small program to print a message in the console. We also learned how to compile and execute C programs and some other features like the preprocessor directive, the main function, and so on. In this video, we are going to dive deeper into the other advanced features of the C programming language, which will allow you to carry out more complex operations with your program. So before we start, consider subscribing to the channel to show your love and support, and don't forget to click the bell icon to receive the future updates as soon as I post my videos. So without any further delay, let's begin. In the last video, we were working on a setup something similar to this, where we are writing our codes in a text editor such as Notepad here, and then in the console we were compiling our code with the GCC command. This is the command prompt for Windows, and then we were trying to execute them to get the result or the output. And we also had a file browser where we can manage all the files that we are creating during the process. But switching between so many windows can become hectic when you're trying to develop large programs. So what we are going to do is, in this video, we are going to switch to something like vscode, which is an IDE or an integrated development environment. It fuses together many features that is required for developing efficient programs. One of them is like an integrated text editor, a console, and a file browser. Other than that, it can also give you suggestions about completing your code before you type it completely. That will allow you to type faster, and also give you some warnings about some mistakes or like some syntax errors or some spelling errors. So compiling and executing the code in VS Code is also very similar. After you writing the code in the text editor, you can go to the console, use the GCC command to compile the file, and then using the by running the a.exe file, you can simply execute the program. So in the last video, we saw that how the printf function can be used to print outputs in the console window. In this program, we are going to do something different, that is the opposite of that. That means we are going to give some inputs in the console, and we will find those values in my program. Now, C program is always about procedures. It's a procedural language. That means it is composed of procedures or functions. And functions are nothing but some operations which are carried out on inputs, and in return some output is provided, right? So let's say in this program, we want to take as input one integer value from our user, and then we want to give back the square of that number. So if the input of the user is something like, say, n, then we want to print the square of the number. So the square of the number can be, say, sq is equals to n into n, right? So if you see this statement, that means I have one variable which will store the value of the squared number, and I have one value n which is going to be the input provided by the user, right? And this asterisk is an operator for multiplication. This equal to is an operator for assignment. That means we multiply n with n, and the assignment will allow us to store the value in sq. Now, how do these variables come into the play? Now, C programming allows us to use variables to store different kinds of values. We have variables that can store integers, we have variables that can store fractional values or decimal values, and also the ones which can store character values. Now, to use variables, we need to declare them first. That means to inform our program that these variables exist inside this environment, and they point to some specific memory locations inside my primary memory where the values are stored. To do that, because we want integers, we are going to use this keyword called int, and then we have two variables that we are using. One is n and one is sq. So let us declare them as int n comma sq. So what it does, in the main memory, that means inside my RAM, it is going to book a couple of locations, that is couple of addresses, and it is going to name them as n and sq. How many locations is it going to store? It depends on compiler to compiler. For example, in this compiler, integer is going to allocate 4 bytes of memory location for each of these variables. In later videos, we are going to have a very detailed discussion about the different types of variables that we can use and the different data types that can be associated with these variables. But for now, let's proceed with the code. So n and sq both are declared, and we have written the equation which will allow us to compute the square. But we have to take the input from the user, right? So just like by using printf, I can print a formatted string in my output. Similarly, to take input, there is a function called scanf. To remember it like this, we can use a printer to print a document which is inside our computer into a paper that is in our hand, right? And we use a scanner to convert the information in the paper in our hand so to a more digital format which is available in the computer, right? We can remember like that. So the name of this function is scanf. Now I'm always using the term formatted string. What is the meaning of formatted string? So let me just show you and then I will explain. Now scanf is going to scan one integer value. I can define it by using a string. So string is defined by double quotes, and inside there the %d, this symbol, it says it represents one integer value. Okay, so this is something which is called as a format specifier. We have different format specifiers for different data types. We are going to come to that later, but for now %d, it means that one integer data type. Oops, I made a small mistake here. Now after getting the input, I have to connect it with this memory location of n, right? Now n is the value. N and sq both are values. We have to ensure that we are copying this data into the appropriate memory location. So for that, what we write is %n, then closing bracket, close. You see this and symbol, it is called as ampersand. This symbol refers to the address in which n is stored. Okay, so this means that we are going to get the input from the user and copy it to the memory location of n. So now we want to print the output, which is this variable square. Okay, so to do that, what we are going to write as, just like here we are writing %d to symbolize one integer that we are going to scan from the console. To print an integer inside the console, we are also going to write as %d. Okay, and what is the value that I want to print? So here we have to print sq. If you notice that I have not used the ampersand symbol here. Why is that? Because when I want to write some value inside my memory, I have to mention the memory location. But if I want to use this value to do some computation or to display, then I do not need to specifically point to the memory location. Just by naming the variable is enough. Okay, once again, while getting inputs, we take the input in the address of the variable, but while printing inputs, we demonstrate the value of the variable. So this code should work. So let's run it and see if it is working. So I am saving the code, gcc test.c. No error, it compiled correctly. If some error comes, it will show it here. Then if I run, and you will see that nothing happens. Nothing happens because it has gone inside the main function. It started with line number 3, that means it has already declared the variables. Now it is executing scanf %d %n. That means it is waiting for my input. That means it is expecting an integer input. So let's say I want to give, say, 5. If I press 5 and press enter, what should be my output? It should do 5 into 5, store it in the variable called sq, and want to print that variable sq. So I should get 25. So let's press enter and see. And as you can see, we have got the output 25. So now we can say that I want to beautify this code a little bit more. So what we can do, we can print a short message, because you see, when we executed our code, we are waiting, we didn't know what we have to do. So we can say printf, please enter a number So this will print this message. After that, we are going to get the input, we are going to do the square, and it is going to print the square. But I want to print this square in a little bit better way. So we can write the square of %d is %d. Try to understand. I have given a string. Inside the string there are 2%d. That means both of these values is going to be replaced by an integer. That means it is defining the format of the string in which it will be printed, right? Now, what is the value of %d? It will be written after the comma. We have to maintain the correct sequence. So first %d should be, so I want to write like the square of 5 is 25. So 5 should be stored in n and 25 should be stored in sq. So I have to write n comma sq, right? So let's see that if it runs now. This is test.c, a.exe. Now you see it gives us a message. It's like the ATM machine, right? When you insert the card, it is asking you, please enter your PIN. Similarly, please enter a number. Let's try a little bit bigger number. So 8. And then I press enter. And it is giving me the square of 8 is 64. Okay, let's try something a little bit different. That means, can we try this with the negative number? Because we know using negative numbers also, we can do their squares, right? So let's run it again. But this time I want to give a negative number. So say -5. And again, the square of -5 is 25. So it gives me the correct output and this program is running very smoothly. Okay. Now, one more thing, just like we were printing multiple values using multiple %d, we can also take input multiple values using multiple %ds. So let's say I want to calculate the area of a rectangle. For that, I need to take as input the length and the breadth, right? So I can say, please enter the length and breadth of the rectangle, right? And then it should ask for two input values. So for now, let us say these are integer values, but I need to declare those integer values. So L for length and B for breadth. And I want to calculate the area. So let me rename SQ as area, right? So length, breadth and area. When I'm taking the inputs, I want to take two inputs. That means 2%ds. So I will write simply 2%ds like this. And then it is, I want to take the input in two memory locations. One is the memory location of L. The other is the memory location of B, right? And the area can be calculated as area is equals to L into B, right? Now let's change the message a little bit. So the area of the rectangle with length %d and breadth %d is %d. So it should print something like the area of the rectangle with length 3 and breadth 4 is 12. So the three values, the 3%ds here are L, B and area, right? So let's see if this works. gcc test.c. So remember, whenever we are changing our code, even if we change one semicolon, then also we have to recompile the code. Okay, otherwise the previous A will run. Once we recompile the code, we'll get the new version of this A file. So please enter the length and breadth of rectangles, 5 and 6. So the area of the rectangle with length 5 and breadth 6 is 30. Now, while entering the two values, you remember there are two ways to do. One is by giving a space in between them. The other is, let's run again. I can use 5, enter, 6, enter. I can also use enter to separate the two values, either space or enter. Right. So one last thing for this video. We were always using this format specifier %d. So this is for integer. What happens when I want to use something like a decimal point, so that a fractional value? So let's say I want to calculate the area of a circle. Now we know area of a circle is pi r square. So pi is a decimal number. So the area will also be a decimal value. So we cannot use the word integer anymore. So we have to use, say, float. Float means floating point values, which are real numbers. So floating point values, and it will be say radius and area. These are the two values that we need. The value of pi is a constant value, we know that. So constants, we can either write it as a number. So let's do that. First, let's take as input the radius of the circle, and we are going to take as input as r. But this time we are not taking input a integer, right? We are taking input a float. So the format specifier for float values or decimal values is %f. Now this should work. Oh, sorry, it is rad, right? So ampersand rad. Now area of the circle is pi r square. So we can write as 3.1415 into rad into rad. Okay. Now we know rad is a float, area is a float, so everything should be fine. So we rewrite the message, the area of the circle with radius as %f. Now because we are using a float is %f. So this will be rad comma area, right? So let's see. Again, we have changed the code, so we compile and then A to execute the code. So let's say 2.4. Now you see I'm giving a decimal number as input, right? So area of the circle with radius 2.4 is 18.094041. Okay. Now let's say we want to use this value 3.1415. This is a constant value. We want to use this at different locations. What we can do, there is one option is that we can use it here. So pi equals to 3.1415. We can initialize it like this. So declaration is just declaring the variable. When we want to define the variable, we declare it. Along with that, we also set the initial value of it, right? So this will also work. So instead of 3.1415, I can use pi and this will work. Another option to do that is, because if we end up writing multiple functions and we want the value of pi to be available in all those functions, we can also do a global declaration. So we can also define it as a macro. So we can do #define then pi. So when you are defining macros, the practice is to use capital letters. That's 3.1415. Okay. Now I do not need to declare it anymore. So this value of pi is available in all the parts of my code. No matter how many different functions that I write inside this, it will be available. So let's execute this. And here you can see that I'm getting the output as usual. Okay, one final tip for writing a program. Whenever we go and write large programs, it becomes very difficult to keep a track of it as time progresses. And most of the time what happens is more than one person is working on the same program. So there needs to be some kind of documentation to define all the different parts of your code. So we can use some things called comments. Okay, so comments are lines that are written within the code, but it is not compiled or executed. Okay, so it is just like a message to the person who is reading or writing the code. So we can say, we can use single line comments using /. Anywhere that we use / is a single line comment. We can use here. So declare the variables. Say variables. So I am writing the message that I want to declare the variables here. Okay. Then let's say I want to write take inputs. Okay. This is, and so this block of code is calculate the area of circle, and this part is display the output. So this messages helps us to read the code better. Imagine that this is a 1,000-line code and we do not have any message. We are going to get super confused as to what are the different variables used and blah blah blah. Instead of writing single line comments, we can also write multi-line comments. For example, to write multi-line comments, we use this two symbols. One is a slash and asterisk, and the ending part is asterisk and star. So whatever we write within this part is a comment. Okay. Let's say this is a program for calculating the area of a circle. So written by Shixak academics, date, say today's date is say 1903. 023. You can also write, say, maybe the version of the code, the version 1.0.0. Like this, you can describe your entire program here as well. So multi-line comments, single line comments. So these are messages for the person who is reading or writing the program. Hash define. So this is a macro definition. This allows us to define some kind of constants and stuff that is available throughout our code. We are declaring variables using some data type like integer or float and some name for that variable. We are printing the outputs that we have already done before. We are scanning the output. We are scanning the input. While scanning, we use a format specifier defining what type of input I want to scan and a address value in which I want to store the scanned result. We can do operations using some kind of operators and the variables, and again we can also give formatted string as outputs which contain format specifiers to display the value of the different kind of variables that we have used in my program. One point to note that while taking input we use the address, that is ampersand the variable name, but while printing the outputs we do not use the address, we just use the variable name. So that's it for this video. In the next video we are going to discuss the different data types that are available to us and also the various types of operators that we can use. And to catch update when that video is posted, don't forget to subscribe to the channel and press on the bell notification. If you have liked the video, drop a like. If you have any doubts, feel free to comment. I will surely answer them. And till the next video, bye bye, see you and have a very good day.